Now after understanding and deriving this equation for the zero order reaction, let us do the half-life. We need to know what exactly is the half-life first, which is represented by T half and is called half-life. See, half-life is the time taken by the reaction to reach to half of its initial concentration. That is, if your time is T half, remember your A, amount of reactant left out, will be A naught by 2, half of the initial one. Therefore, what we can make out of that integrated rate equation is, since K is equal to A naught minus A by T, this equation can be written as A naught minus A naught by 2, because we will replace this A by A naught by 2 and we will replace T by T half. So what simple formula we get is that we get T half is equal to A naught upon 2K. This is the formula which we get for the half-life of a zero order reaction. So we need to remember basically the two formulas for zero order. The one is this one, the rate equation, or we can write Kt is equal to A naught minus A, and the second is the half-life equation, which is A naught upon 2K. Both of these are very important reactions. Now before moving further into the numericals of this, let us first understand certain graphs for the zero order reaction. Now remember, for zero order reaction, like if we plot a graph between rate and concentration, remember it will be parallel to your x-axis, because rate doesn't changes with the change in the concentration, as it is independent of concentration, because it's a zero order reaction. The second graph, we know if we plot half-life with concentration, it will be straight line passing through origin. The reason being, we know the formula that T half is equal to A naught upon 2K. So it is directly proportional to initial concentration. Another important graph we can make out, which is actually for the zero order equation. We know that equation is Kt is equal to A naught minus A. We can do slight change, we can bring it here. It become A is equal to A naught minus Kt. Now we can compare this equation with y equals to mx plus c. What we get is, we can draw a graph and we can compare. Here y is your concentration of the reactant A, x is the time. We get a straight line which intercepts y-axis at A naught, and the slope tan theta is equal to minus k. So these are the basic graphs of the zero order reaction, and we know now the formulas of the half-life as well as the rate equation, the integrated rate equation for the zero order reaction.